The YF-23 Black Widow II stands as one of the most fascinating and mysterious fighter prototypes ever created in the history of American aviation. Developed by Northrop and McDonnell Douglas for the United States Air Force Advanced Tactical Fighter Program, the aircraft was designed to achieve complete air dominance in the 21st century. Although it ultimately lost to the Lockheed Martin YF-22, which later became the F-22 Raptor, the YF-23 remains admired by aviation experts for its extreme stealth, innovative aerodynamics and futuristic performance profile. This aircraft demonstrated capabilities that were in many ways ahead of its time, and its legacy continues to influence modern aerospace engineering. The YF-23 was built around the demanding requirements of speed, survivability, stealth and operational flexibility. The U.S. Air Force wanted a next-generation air superiority fighter that could outperform Soviet aircraft, penetrate dense air defenses and dominate long-range aerial engagements. To meet this challenge, the YF-23 introduced a radical design unlike anything seen before. Its diamond-shaped wings, blended fuselage, and distinctive V-tail gave it a smooth, predatory silhouette that reduced radar signature to a minimum. Every line and angle was shaped deliberately for stealth, and this made the aircraft extremely difficult for enemy radar systems to detect. In fact, many analysts believe its stealth profile was superior even to the F-22 in certain angles. The performance goals of the YF-23 pushed engineering to the edge. The aircraft was designed for supercruise, meaning it could sustain supersonic speeds without using afterburners. This gave it a massive advantage in fuel efficiency, long-range operations and tactical surprise. Reports from the time indicate that the YF-23 achieved speeds estimated above Mach 1.6 in supercruise and could potentially reach speeds above Mach 2 at full thrust. Two prototypes were built, named PAV-1 and PAV-2, each powered by different engines for testing. The first used the Pratt & Whitney YF-119 engine, while the second used the General Electric YF-120 variable cycle engine, which was extremely advanced for its time. Both setups delivered excellent performance and impressive acceleration. One of the biggest strengths of the YF-23 was its ability to stay hidden. The aircraft used internal weapons bays to avoid compromising its stealth shape. It was designed to carry advanced air-to-air missiles such as the AIM-120 AMRAAM and AIM-9 Sidewinder. The bay doors opened and closed quickly to minimize radar exposure during missile launch. Unlike the F-22, the YF-23 prototype did not include an internal cannon, but the production version could have accommodated one if required by the Air Force. The aircraft was optimized for long-range, high-altitude interception and air superiority, meaning it was designed to detect and neutralize threats long before they could detect it in return. The aerodynamic layout of the YF-23 provided exceptional high-speed stability and energy efficiency. The wide, blended wing and body structure reduced drag while the V-tail minimized radar reflections and offered stable control across different flight regimes. Test pilots reported that the aircraft handled smoothly, responded well in high-altitude operations and delivered excellent performance during test evaluations. Although the YF-23 was less agile than the YF-22 at low speeds and during sharp maneuvers, this trade-off was intentional. Northrop prioritized stealth, speed and long-range superiority rather than close-range dogfighting. Their philosophy was to create a fighter that could destroy the enemy from afar before visual contact was even made. In terms of survivability, the YF-23 incorporated advanced composite materials, heat reducing structures and innovative engine placement that helped minimize infrared detection. The engine exhaust was shielded deep within the body to reduce heat signature, making the aircraft much harder for heat-seeking missiles to lock onto. Its large internal fuel capacity allowed extended range missions, supporting operations deep inside contested airspace. This combination of reduced radar signature, reduced heat signature and high-altitude capability made the aircraft extremely difficult to detect, track or intercept. The cockpit of the YF-23 featured modern avionics for the time, including advanced displays, sensor fusion concepts and ergonomic controls that gave the pilot simplified access to mission-critical information. Although the prototype did not feature the full suite of sensors planned for the operational version, the final aircraft would have included advanced radar, electronic warfare systems and a powerful sensor fusion network that allowed seamless coordination with other aircraft and command centers. Despite its impressive performance, the YF-23 was not selected for production. The Air Force chose the YF-22, later the F-22 Raptor, due to its superior dogfighting agility, ease of maintenance and Lockheed Martin's manufacturing approach, which the government considered lower risk. However, many aviation experts argue that the YF-23 offered unmatched stealth characteristics and better long-range performance. Some analysts believe that if the YF-23 had been selected, the U.S. Air Force would have received a fighter with greater stealth at long range and improved survivability in deep strike missions. Even though the YF-23 never entered active service, its influence did not disappear. The aircraft inspired later stealth designs and remains a reference point for future sixth-generation aircraft. Its aerodynamic shape and stealth concepts have been studied by engineers working on next-generation projects such as NGAD and other advanced U.S. fighter programs. Only 2 YF-23 prototypes were ever built, and both remain preserved in museums as silent reminders of what could have been one of the most advanced fighters in American history. Today, the YF-23 Black Widow II is admired for its bold engineering and for representing a different path the Air Force could have taken. It symbolizes innovation, ambition and the pursuit of stealth perfection. Aviation enthusiasts around the world continue to discuss how this aircraft might have performed if it had entered production and how its unmatched stealth and speed might have shaped modern aerial combat. The YF-23 remains a legendary example of American aerospace excellence and a testament to how cutting-edge engineering can push the boundaries of technology.